Okay, welcome back. This is the bonus video. So we take a look into another approach on how to solve this challenge. And I would like to provide this to you to see there are lots of opportunities we've already got to solve this challenge. Okay, so let's see. First, let's get this application screen back. So this is our root check here. Yes, our device is rooted. All right, so this is the application. And now we want to bypass this by patching the labels. So we close this one and we go into apps. Then, well, the root check. There we go. Okay, we first decompile this application. Then we open the whole Smiley directory with Visual Studio Code. All right, then we go into app hacking and then the root util. There we go. We click away those annoying windows, select Java, click it away. All right, let's open it up on the decompiled version right next to us. So jdx GUI rootcheck.apk. Okay, so I've got my graphic tablet out and we are still talking about the isDevices_rooted method. So if we go down, there we go. So here we can see, okay, we've got several checks. Check root method 1, 2, and this one is 3. There we go. Okay, so this is the method on the Java side, and let's take a look into the Smiley part. So here we have our method, isDeviceRooted. This returns a Boolean value. Then we've got our 3 checks over here, and these are combined with an OR statement. So with this one over here. Let's analyze this real quick. Okay, we start at the beginning. Is device rooted? No parameters, Boolean return value. So we've got a local variable, a local register over here. Then we've got our line 10. And then we've got our first invoke static. This is the class name, root util dot check root method 1. Okay, this result gets moved into v0. So this means our v0 is root util dot check root method 1. And so on. Then we've got our if statement. So we've got this and this. Next we've got our if statement. If v0 is not equal 0, we jump to condition 1. If v0 is not equal 0, we jump to condition 1. Condition 1 is this one here. So we jump down here. And yeah, before we take a look into this, let's analyze this real quick. What do we have here? Okay, this means if our v0 is not equal 0, it means our v0 is set to 1, which means the return value of this function over here, this one here, has been 1 in the case of a true statement here. This means we've got a routing detection, or the routing detection signals identified something strange on the device and it flags it as being rooted because we have here a Boolean value. So check root method 1 returns true and then we know, okay, this device is rooted. This means we go into the condition 1 over here. We've also got this goto label, but we can ignore this. And then we write 1 into our v0. And we return out. But with the return value of v0, which is 1. And this means it's true. And this means isDeviceRooted becomes true. And this means this is bad, at least for us as an attacker, because then our device is being flagged as rooted. Therefore, we know every jump condition which ends up here in this part will be the true case. This means our device is rooted. And this means every jump to condition 1 and also the go to 0 label will make or will flag our device as being rooted. Okay, so let's clean this up real quick. These 3 here mean device is rooted. Okay, so regarding to our check, we've got our check over here. This one is device rooted. Then we've got true. The device is rooted. And we've got false. True means we end up at condition 1. And also with the go-to label 0. Okay, let's see where we end up if we want to get our false statement here. So which jump instruction we need to get to have this false enabled. Okay, so if this one is true, we go downwards. Therefore, this is our false statement. Okay, then we have this once again for method 2. We move this in v0. All right. So v0 once again, not equal 0. We've got exactly the same code over here. All right, here we can see true. We still end up in condition 1, which means our device is being rooted. Therefore, if this one is also false, we move check root method 3 into v0. Oops, wrong color. Okay, and then we've got if equals 0 v0. So let's write this down here. So if v0 is equal 0, we jump to condition 0. If v0 is equal 0, we jump to condition 0. Okay, when v0 is 0, it means v0 is false. So our check root method over here will return false if we go into condition 0. And condition 0 is this one over here. So we move the value false into v0. And afterwards we go to label go to 1, which is this one over here. And then we return out. So this means we are returning v0. Okay, if we look at this, let me clean this up a little bit. Okay, so if we get into this jump over here, condition 0, then we end up here. This will move false into v0, and then this one is a jump we always take if we are at this line, because this is a jump instruction go to and also the label. So if we end up at this line, or let's say in condition 0, we also take this jump to go to 1. And go to 1 simply skips this bad code over here, which moves true into v0, and this is not what we want to have. Therefore, we know our false condition is set to, let's see, condition 0. Okay, so now let's adjust our labels, no matter what's the output, to always go this way, even if it would have taken this way. So we get rid of this path, and we direct all of these jump instructions to this path over here on the right. And we can do this by simply adjusting all labels to condition 0. So if this one is condition 0 and this one is condition 0 and everything is condition 0, then there's no option to get into another branch over here. So we've got no option to get into this one. This one is out right now. And we only can reach condition 0, which means we are putting false into v0, and then we are leaving out this function. So this will be code that can never be reached again. Alrighty, let's adjust this patch. It looks a little bit messy, but I guess, but I hope you could follow on this. Alright, so let me clear this up. And now let's do the patch. All right, by applying the patch, we do not have to consider, is this now a true or false statement? Do we have our test keys enabled or not? This is things we need to care about if we flip the logic, but not if we adjust all labels over here. So in this case, this is simply our false, this one over here, and therefore we direct all to this one right now. So this becomes condition 0. Also, this becomes condition 0. This one also becomes condition 0. All right, and I guess that's it. Yes, even if this check fails right now, we jump to condition 0, which is this one over here. All right, this was the only thing we have to take care about, because now we've got a reversed logic. Let's say it in this way. Here we are checking if it's not equal 0. Now we're checking if it's equal 0, but by changing the label also to go to condition 0, which is, where is it? There is it. It's directly underneath. I do not see this. Okay. If we change it in this way, then we do not get into this one, and this will become dead code. I'm also super excited how this application looks like if you patch it in this way. I guess there will be some hard-coded statement, something like return false, but let's see. Okay, one thing I want to additionally add to this video is, if you patch those labels, you need to be pretty careful, because you can accidentally create endless loops, and this can happen super easily. I would like to show you what I mean over here. So over here, for example, we have this jump to condition 0. Here we are also having a jump to condition 0, and this one over here. Here we are having an additional jump to condition 0, and here we are having our condition 0. So this is our patched version. And if the compiler is creating this code, the compiler makes sure that the program flow is correct. But now if we get into this control flow and patching it, we need to make sure that the control flow is still correct. Because what can happen is the following. Over here we're having now all these jump labels to condition 0. So let's say this one on the right is our program code. Okay, so here we're having our program code. And this one over here, this is, for example, the jump to condition 0. And let's write it down in the following way. Condition 0. This is also the case over here. And this is also the case over here. And this one over here, condition 0. And now finally, where do we have it? Here we're having it. Okay, so this one over here is then finally our condition 0. It's not that straight anymore, but it's still our condition. So this means all these jumps end up over here. And this is perfectly fine. So here we are ending up with all these jumps. All right, this is okay so far. But it could be easily the case that this condition 0 over here is not related here at our program code. So let's say this condition 0 is, for example, in between them. Let's say this condition 0 sits here. And this is now our condition 0 label. So what happens right now? Let's remove this part. So now our condition 0 is here. And this means this jump, the first jump, and also the second jump are referring to this one, okay? But now we could have a problem, because after this one over here, we are having a jump back. This could be an invalid case. For example, if we're having a for loop, then we are also creating a case like this one. So this is our for loop. And within a for loop, we are also having these conditions, for example, this block over here. So within the for loop, we jump, for example, back to this one, then we subtract -1 from I. Let's write it different. I minus, and then we will leave this conditional jump, this loop, if I is less than equal 0. And then we break out of this one and we move on with our original code. So this could be a valid behavior, but in our case right now, we have modified this jump label and we are not having a condition when we leave this code. This means we are having now the following case. So let me clean this up real quick. So we are having now this condition 0. And let's say we move on at this point in our program code. And then we end up at this point over here. At this point, we are jumping back to condition 0. Okay. Then the program once again goes down until we once again are at this point. Oh, we are jumping back to this point. Once again, the program and so on. I guess you get this point. Here we are having now an endless loop. Endless loop, because we are not having a condition to break out of this one. And this is the case because we have modified additional jump instruction. For example, this one over here, this has not been, I'm not sure if this has the case right now, but in our case right now, let's assume this has been conditional 1 before and this one also. If conditional 1 is underneath, like this one over here, conditional 1, then those jumps are definitely correct because they have been created by the compiler and the compiler have taken care of this one over here. Jumps doesn't have to go always down. They could be also correct if they go upwards, but then there are certain conditions that we do not end up back in this, in an endless loop like over here. But if we modify them that they are not going this way, that they are going back to condition 0 over here, then we need to really take care of this one over here. All right? Okay, so if you adjust a lot of labels in your code, maybe draw this on the right and make sure that you're not accidentally created an endless loop like we're having at this case over here. So this one over here, that's an endless loop. Okay, now let's get back to the video and move on. First, we apply our patch. Okay, so we hit the save button multiple times. All right, then we build this application. All right, and now, oh no, it's not possible in this way. ADB install because our APK is named out APK. Alrighty, screen copy, slide up, root check. There we go. We've also successfully patched it by adjusting these labels. Nice. Is login possible? Yes. We've got really insane smiley skills right now. Nice. All right, and let's have a quick look into what this application now looks like regarding to the Java code. Com and root check, root util. Yes, exactly. I didn't look it up, but I've got this feeling that it exactly turned it in this way. All right. Nice, super nice. Okay, so we can also adjust our labels, but we have to understand the code. The code, which is within the Visual Studio file I already closed, this one over here. So if we identify what's the condition we want to end up, we can simply adjust all other labels to jump to this condition, which is this one over here. Okay, so I hope this helped you if you tried this approach. It's not that easy to think about this if you start learning Smiley, but I guess this approach can be also super helpful to you in the future. Therefore, I would like to make an own separate video regarding to this one, because you also do not see this very often in the wild. Okay, so that's all for now. In the next section, we take a look at objects and methods, and this will be even more exciting because we are going to insert our own code into the Smiley part. Not just in single instruction like this one, we insert own code. So I see you there.